Good afternoon, students. So till yesterday, we have seen the different types of technology threats that might come during any e-commerce transaction. So today on, we are going to see what are the different technology solutions that can help you to overcome those threats. Okay. So as a part of the second topic of module 3, we are going to see the technology solutions which can help you tackle with threats that can come during any e-commerce transaction. So how to protect internet communications? So as we know, any e-commerce transaction is going to be handed over. That is, it's basically implemented with the help of internet and communication medium. So e-commerce transaction basically uses the public infrastructure, that is your internet, in order to accomplish the transaction, and therefore it involves thousands of routers and servers through which the transaction packets should go. So your transaction has to complete. Before it's getting completed, it got to travel through several routers, several machines, intermediaries, and several other networks as well. So you require a total security of the communication medium in order to ensure that your transactions go uninterrupted. So the greatest threats occur at the level of internet communications, because without internet there is no e-commerce. So you need to have protection done basically on internet communications. A number of tools are available to protect the security of internet communication, and the most basic is message encryption. That is the first step to protect any particular data that is going to be transmitted through a communication channel, basically in the case of e-commerce, the internet. So the first fundamental step is to encrypt the messages that are going to be transmitted. So these are the different tools that are basically used to ensure security to e-commerce sites. So tools available to achieve site security. So these are encryption, network security protocols, VPNs, virtual private networks, tunneling, then proxy servers, firewalls, then security tools, access control methodologies, authentication mechanisms, intrusion detection mechanisms. So these are several tools that will help you to have e-commerce site secured. Okay, so we're going to see about all these tools. So the first step to protect any particular message that is going to travel over a communication medium, basically the internet in the case of e-commerce, is encryption. So that is the first step. So since you people are learning cryptography paper, you will be knowing what is encryption, and you will be knowing basics of cryptography, but still we'll be looking on to the basics of cryptography in this particular topic as well. So we have encryption as the process of transforming a plain text which is in the intelligible form to another form which is totally unintelligible. Okay, so you're going to use appropriate cryptographic algorithms and keys that will be helping you to convert a message from plain text to an unintelligible form. So it is going to be, the plain text is what which is directly it can be written and it is intelligible, and it's going to be converted to a non-intelligible form, that is cannot be interpreted directly. So that is basically called as the ciphertext. Okay, so it cannot be directly read by anyone other than the sender and the receiver. So you're going to convert a message in plain text to an unintelligible form, which is the ciphertext, and this ciphertext can be converted back to plain text only by two people involved in the transaction, that is the sender and the receiver. Now what is the basic purpose of encryption? So in order to have, why we encrypt our messages is to secure our information from a third party. It's like to whom the message is intended, who is the source, who is going to send the message and who is going to receive the message. Only those two people should be able to get the message. There should not be any other third person who can get the message. Okay, to secure the information during transmission without any particular intruder coming in between and taking up your message. So in order to prevent that, you require your message to be encrypted. So those are the two purposes of encryption: in order to protect your message, in order to prevent your message from being taken up during transmission or being altered during transmission. So these are the two main objectives behind encryption. Now, encryption can provide 4 of the 6 dimensions of e-commerce security. You remember? Hope you are remembering the 6 dimensions of e-commerce security: availability, access control, then we have authentication, non-reputation, all these things, integrity, all these we have seen. Okay, so encryption is going to satisfy 4 out of the 6 e-commerce security dimensions. So first one is integrity. It ensures that whatever message that is going to travel from a sender to receiver is going to be received in the same form in which it was initially sent. It is not getting altered in between. It is not getting changed by a third person during transit. Okay, so in which form it was sent, the very same form it is getting received. So that is integrity. Now, non-reputation in sense, the two parties who are involving in the transaction will never deny the transmission of a message at a later point of time. So preventing the users from denying the action. So once a source has sent a message, at a later point the source should not deny that he has sent such a message. So this is the act of non-reputation. That is not possible because there is a prior communication that basically happens when an encrypted message is going to travel. So you have the keys as well as all those necessary information that is going to be shared between the sender and the receiver beforehand, before the actual message is going to be transmitted. There is a sort of communication that happens. So because of that, you can ensure the identity of both the entities, and both the entities know that they are about to transmit. They are going to, so the center knows that he's going to transmit, and the receiver also knows that he's going to receive a message from the center. So they cannot at a later point deny this action. Now, authentication. So before any particular message is going to be transmitted, the authentication of both the source and the receiving end is going to be properly authenticated for their genuinity. So we verify the person's identity or the computer which is sending the message. So both the ends are getting authorized before the actual data transfer can happen. Then confidentiality, we ensure that the message is not read by others, because we are going to send the message encrypted, totally encrypted, so that even if any person is accidentally it's able to intrude into the communication channel and get away the message, then also it will be difficult for the intruder to convert it back to the plain text and thereby interpret the contents. Okay, so since encryption is possible, we can have confidentiality achieved. So these are the 4 e-commerce dimensions out of the total 6 that is going to be satisfied by encryption method. Now we have what is meant by ciphertext. Okay, so a text that is readily readable in plain English form, that is the plain text. Now, a text that has been encrypted and cannot be read by anyone directly other than the sender and the receiver, and which is in the non-intelligible form, is called as the ciphertext. So we have a code where letters of the message are replaced by another letter. So we have got, depending upon the type of encryption algorithm you're going to use, you have a particular method by which each and every character in the plain text is going to be converted to another character. So we have got, depending upon the algorithm, it differs. The way in which the letters are getting replaced, that will be differing. Okay, so anyway, you're going to have each and every character or letter in the plain text getting replaced by another set of characters. So the transformation of plain text to ciphertext is accomplished by using keys, okay, or ciphers. So we are going to use certain cryptographic algorithms, as well as we are going to use certain keys which will help us to convert plain text to ciphertext. In other words, a key or cipher is any method of transforming plain text to ciphertext. So in order to convert a plain text which is in the human readable form, and in order to convert it into an unintelligible form, that is the ciphertext, we use specialized keys for the purpose. Now we have substitution cipher. So as the name indicates, a substitution cipher is created by transforming or substituting every occurrence of a letter is going to be systematically replaced by another letter. So we have every letter in the plain text getting systematically replaced by another letter. For example, we have used the cipher letter plus 2, meaning every letter in the word with a letter 2 places forward. So for A, we'll be using B and C. D, A will be replaced by D. Likewise, we'll be shifting 2 letters. Okay, each letter will be replaced by a letter by shifting 2 letters forward. Then we have the word hello in plain text would be transmitted into the ciphertext J, G, N, and Q. So H, for H we have H, I, J. Okay, so 2 character forward. Then for E, F, and G. For L, M, N. Another L, another N. Then O, P, Q. So we have H is converted, substituted by substitution cipher. The letter H is substituted by a letter 2 letters forward. So after H we have I and J. So H is replaced by J, E by G, L by N, the second L also by N, and O by Q. So this is how you get from a plain text, how can you get a substitution cipher. So for every letter in the plain text will be substituted or systematically replaced by another set of letters. So in this example we are going to have every letter in the plain text will be substituted by a letter 2 letters forward. Then we have transposition ciphered. So transposition cipher is the ordering of letters in each word is changed in some systematic way. That is reverse order, 2 letters ahead. Okay, so likewise we have transposition cipher. We'll be sorting it in the descending order, reverse order we can put it in the reverse order. That is hello, we can put hello as O-L-L-E-H, likewise we can put. So in the order can be reversed, or else we can put 2 letters ahead, likewise just as we saw before. So that is transposition cipher. Transposition cipher. So we have 2 types of ciphers here. One is substitution cipher, second is transposition cipher. They use the very same methodology. A set of characters is going to be replaced by another set of characters in some systematic way. We'll be following a procedure whereby substitution or transposition happens. Now we have the different types of encryptions. Okay, so first one is symmetric key encryption. So in order to decrypt, see what is encryption and what is decryption, you'll be knowing. Encryption is the actual act of converting a plain text to ciphertext, and decryption is the opposite of that, from the ciphertext getting back the plain text. Okay, so encryption happens at the source end, decryption happens at the receiving end. Hope you will be knowing all these since you are learning that paper, cryptography. Okay, symmetric key encryption. So in order to decrypt the messages, the receiver would have to know a secret cipher that was used to encrypt the plain text. So what was the key that was used to encrypt? The very same key should be used to decrypt as well. So the key with which the sender has encrypted the message, that should be known to the receiver in order for the receiver to decrypt the message back to the plain text and thereby interpret the contents. So this is called symmetric key encryption or secret key encryption. Okay, so we have a particular key that is used to convert plain text to ciphertext, and at the receiving end we are using the same key again to convert ciphertext back to plain text. So this is called as symmetric key encryption, and since this key will be known only to the 2 people involved in the transaction, it is kept as a secret between these 2 people. It can also be called as secret key encryption. Now, symmetric key is both sender and receiver will be using the same key to encrypt and decrypt. So it is called as symmetric. Symmetric in sense same key. So the sender and the receiver will be sharing a secret key, and this key will be the same. The key with which the sender has used in order to encrypt the message, the very same key is going to be used by the receiver in order to decrypt the message. 2 keys are same. So it is called as symmetric key encryption. So the key is sent over a secure line or exchanged in person. So either the key, so before any communication can start, before the actual data can travel through the communication medium in the encrypted form, we got to have the key transmitted first. So unless otherwise the receiver has the key, he won't be able to decrypt the message. So the key is going to be sent through a very secure channel, that is one way, or else the key is going to be exchanged in person. The possibilities for symbol substitution and transposition ciphers are endless, but they all suffer from common flaws. There are different variety of mechanisms you can follow in order to replace a set of characters or set of letters in the original plain text to ciphertext. There are n number of methods in which you can do. Okay, but every method has got disadvantages as well. In the digital age, computers are so powerful and fast that these ancient means of encryption can be broken quickly. So we can write certain programs which can find out n number of combinations whereby a transposition cipher can be created or a substitution cipher can be created. Okay, so we can make use of computers to create different sequence of combinations wherein a message can be converted, wherein a transposition cipher or substitution cipher can be created. So in this digital era, encryption method has got lot of disadvantages. So sender and receiver will be using the same digital key to encrypt and decrypt the message. So it requires sophisticated mechanisms to securely distribute the secret key to both the parties. See, secret key is the only mechanism that you have. Once the key is lost, your text can be easily gone back. Your plain text can be easily gone back from the ciphertext. So it requires different set of keys for each transaction. So the key that was used for one transaction cannot be used for another transaction. The key has to be changed. Okay, so that is, there are different, there are different loopholes in this. We can have, the attacker can use different methods to penetrate into. So this type of encryption technique using transposition and substitution ciphers can be easily broken as well. So modern encryption systems are now digital. So cipher keys used to transform plain text to ciphertext are digital strings nowadays. Now computers store text or the data, as we know, in the terms of zeros and ones. So for example, binary representation of letter A in ASCII computer code is accomplished with 8 binary digits. That is the binary representation of A. This all you know. Now one way in which digital strings can be transformed to ciphertext is by multiplying each letter by another binary number, say 8-bit binary number, binary 8-bit key number. Okay, so this is another way whereby a ciphertext can be created from an ASCII code. So provided you have a plain text, and in the plain text each letter is going to be converted to the corresponding binary representation, and then it can be multiplied by, each letter can be multiplied by another binary number that is called as an 8-bit key number. So this particular number is used to multiply. So each and every letter's equivalent binary is going to be multiplied by this key number in order to generate the cipher. So if we multiplied every digital character in our text message by this 8-bit key, then the encrypted message to a friend along with the secret 8-bit key, the friend could decode the message easily. So this is another one method in digital era. Since in digital era computers basically store data in the form of zeros and ones, here also we are using the 0 and 1 method. So in the plain text, each and every letter will be having the corresponding binary representation. Now we are going to have this binary representation of each letter in the plain text getting multiplied by a secret key number, 8-bit key number, and then you generate the ciphertext. And once this secret 8-bit number is going to be given to the receiving end, the receiver can easily decrypt the message. So this is one technique that is followed in the digital era in order to convert plain text to ciphertext. Now, what is the basic strength of encryption? So far we have discussed the different methods of converting plain text to cipher through substitution, can be using transposition, and this is by using the equivalent equivalent binary representation and multiplication by a 8-bit key number. So strength of encryption. So length of binary key used to encrypt the data, that also decides the strength of your encryption technique. Okay, so depending upon the size of your key, the strength of your key also basically decides the strength of encryption technique. 8-bit key is easily decrypted because there are only 2 raised to 8 or 256 possibilities. Okay, you can have different combinations of zeros and ones in order to find out what is the secret key. Once the secret key is got, you can easily get back the plain text. So that is the case. The secret key is the one information that is shared in common by both the source and receiving end. So an intruder can have, since it is an 8-bit number, the number of combinations you can have is 2 raised to 8 or 256 combinations. That the intruder can easily try different combinations. All those 256 can be easily generated, and he can try out with all those and easily find out the 8-bit key number that was used to encrypt the message. So that is one main drawback. You have immense of algorithms available, immense of possibilities. With the aid of a computer, you can generate all those possible key combinations and you can try out. Okay. So for this reason, modern digital encryption system uses keys with 56, 128, 256 or 512 binary bits. So we can have n number of combinations. Now you're using many type of methods and mathematical methods to have the ciphertext generated. You can use see, I've seen one research paper in which one table called Vigenère. And this is one mathematical table that is basically used in order to have, so that is a matrix 10 into 10 cross 10, I believe, or 12 cross 12, I don't remember. So it is a table in which you have all these numbers there, and you basically shuffle it. The rows and columns are getting shuffled, and likewise you can create n number of possible key combinations to convert your plain text to cipher. So it's very difficult to find out the key. So the more difficult it is to find out the key, the more strong your encryption becomes. Okay, because key is the only thing that you have in your hand in order to get back the plain text. So stronger the key, stronger the encryption. Now we have data encryption standard. It's developed by National Security Agency NSA and IBM. It uses a 56-bit encryption key. So digital encryption standard uses a 56-bit key combination in order to convert plain text to ciphertext. Then we have AES standard. So widely used symmetric key encryption technique, and it uses 128 and 256-bit encryption keys for converting plain text to cipher. Now other standards use keys up to 2048 bits. So more bit combinations you use, stronger your key becomes. You can have different combinations. You cannot actually get all the combinations because there will be a lot of combinations you can have for keys, and you can use separate key combination for each and every transaction, so that it will be very difficult for an attacker to find out the key and thereby decrypt the message. Now we have the encryption technique, which is public key encryption. Public key encryption technique. So this is a cryptographic system in which we are going to use two types of keys. One key which is a public key that will be known to all. Second is a secret key. Okay, so we have two keys used here. So public key that will be known to everyone, and the private key or secret key known only to the recipient of the message. Okay, so that is the usage of two keys, one which is kept as public, one which is kept as private. Okay, one key will be known to both sender and receiver, another key will be private to the receiver. Example, when John wants to read a secure message to Jane, he uses Jane's public key to encrypt the message, and Jane then uses her private key to decrypt it. So the sender will be sending a message by encrypting it with a public key that will be known to both the sender and receiver, and the receiving end will be having a secret key which is called as the private key, and the message is going to be decrypted with the private key. An important element to public key system is that public key and private keys are related in such a way that only the public key that can be used to encrypt the message and only the corresponding private key can be used to decrypt. So there is some sort of a combination that should go between the private key and public key, so that any message that is going to be encrypted with the public key can be decrypted only with the corresponding private key. So there is a combo between the private and public keys that should be framed in such a way. So once the keys are used, they are no longer be used to unencrypt the message. They are one-way irreversible functions. So once a key combination, a private key public key combination was used to transmit a message, it cannot be reversed, like the public key becomes private again and a private key becoming public again. So the combination, one combination suits only for one transaction. It's not irreversible. It's not reversible actually. It is irreversible. It's not reversible. Now mathematical algorithms are used to produce keys are one-way functions. Okay, one way in sense it's not reversible. You cannot reverse a key combination. A key combination serves only in one direction. It's not reversible. It serves only one transaction. So this is just a diagrammatic representation of the encryption mechanism. So we have a sender. We have the plain text that the sender is going to send to the receiving end. Now we're going to use an appropriate encryption algorithm. So here in this case, we're going to use a public key cryptography. It's going to use a public key. The sender is going to use a recipient's public key in order to encrypt the message. And after the message is being encrypted, it's converted to ciphertext. And at the receiving end, the receiver is having a secret key, which is his private key. With the recipient's private key, the message is going to be decrypted and converted to plain text, and it is intelligible to the recipient. Okay. So this is the basic diagrammatic representation of public key cryptography. So this is also another example that is given. So we have a sender, that is original message in plain text by Cisco at $16, and we have recipient's public key getting used in order to encrypt the message and convert it into cipher. So ciphertext is in the zeros and one representation, and then the particular encrypted message is going to travel across the communication medium, and at the receiving end we have the recipient's private key that is used to convert the ciphertext back to the plain text, and then it is going to be read by the recipient. So that was two types of encryption techniques we discussed. One is public key encryption, and then we learned about symmetric key. Okay. Now we are going to have public key encryption using digital signatures and hash digest. Okay, this is another mechanism. Public key encryption technique using digital signatures and hash digest. So in public key encryption, some elements of security are still missing. So although we can be quite sure that the message is not understood or read by a third party, there is no guarantee that the sender is really the sender, and there is no authentication of the sender. So here in the case of encryption technique, all the focus goes to what? The message being converted to cipher, so that it becomes unintelligible. It becomes unintelligible to the intruder. Okay, so message getting converted to cipher. All focus goes on the encryption part. But there is a very important part to be focused on, that is the authentication of the sending end and the receiving end. We need to have a proper source. We need to ensure that the message is coming from the correct source, whether the source end is properly authenticated, whether the identity of the source is correct, whether I'm going to receive the message from a genuine source. Okay, so I need to verify the identity. I should authenticate the identity of the source end from wherein I'm going to receive the message. So I should convince myself that the message that I'm going to receive is coming from a valid source that need to be authenticated. I need to convince myself. Then only there is any purpose for reading the message. Message should be from the correct person. So to check the confidentiality of the message and to ensure that the message has not been altered during transit, we use a hash function to create a digest of the message. So the basic function of a digital signature is to authenticate the source. If we have a message with a digital signature of the source end, then we can assure that this message is coming from this valid source. Okay, so that is the purpose of that is the purpose of digital signature. And a hash digest is basically a hash code that is basically used in order to assure that the message has not been altered during transit. Okay, when the message is not altered, we have a proper hash codes, that is hash function that is going to be used in order to create a message digest. Okay, it's called as the digest of the message. So hash function used to convert message to message digest. So these two things have got two different responsibilities to do. One is digital signature in order to properly authenticate the source, in order to assure that the message is from a valid person, valid source. So if we have a message along with the digital signature of the source, then we can assure that it is coming from a valid source. Similar, the hash digest has got another responsibility, that is to assure that the message has not been altered during transit. So for that, the hash method will be using a hash function in order to create a message digest. Now hash function is nothing but an algorithm that produces a fixed number called hash or message digest. It will be generating a number. It is an algorithm that results in a number which is called as the message digest or hash. Now hash function creates fixed length number that replaces the original message Then the hash is used to recreate the message on the recipient end. So this hash is a number. That number is a fixed length number that will be replacing the original message. And at the receiving end, this hash will be replaced by the original message. The hash will be used by the recipient in order to recreate the message. So an extra security that is applied on the message in order to prevent any alteration of the message during transmission. That is basically hashing. So entire ciphertext is encrypted with the recipient's public key and sender's private key, creating the digital signature for authenticity and non-repudiation. So in order to have a digital signature created, the entire ciphertext is going to be encrypted with the recipient's public key and the sender's private key. So sender will be having his own private key and the recipient's public key, that is basically used in public key cryptography in order to encrypt the message. And then we have the digital signature getting added so that the source is going to be authenticated perfectly. Then digital signature is the type of electronic signature that encrypts documents with digital codes that are particularly difficult to duplicate. So digital signature is a set of digital code, and that will be provided by the source. Each source will be having their own, each and every source end, that is the sender, will be having his own digital signature, which is a set of digital codes which is very difficult to recreate. So that will be attached to the message. So whereby we can actually validate the identity of the source, and also we can prevent non-repudiation. The source which is send a message with his digital signature can never deny at a later point that he has not sent such a message, because message holds the identity of the source. Okay, so we'll be having a message with a digital signature, so that it will be authenticating the source as well as it will be preventing non-repudiation, since any particular message that carries the sender's digital signature can never be actually the source can never cannot be denied by any source. Any source cannot deny that it is not his message, because he has not sent such a message, because the message has his digital signature. Then digital signature is a signed ciphertext that is sent over the internet. So to encryption technique, the main focus, since it goes on to converting plain text to ciphertext, these are two methodologies which will help us to have encryption and thereby security that is enforced on the particular message to be we can enforce more security. Okay, encryption technique can be made more strong, even more strong, by using two more things. One is the digital signature and second is the hash function. So these are the steps in public key cryptography with the help of digital signatures. So the first step, the sender creates an original message. Second, sender applies hash function producing a 128-bit hash result. So we have a hashing algorithm that will be generating a numerical result, a fixed length number. Now the sender encrypts the message using the hash result using the recipient's public key. So encryption is done with the recipient's public key as well as using the hash code. Now the sender encrypts the result and again with his own private key. So the second type of encryption is done with the sender's private key. So we have encryption done using initially with the recipient's public key, then using the hash code, then with the sender's private key. Okay, so this is basically called as double encryption, because we are encrypting initially with recipient's public key and the hash code, and then encryption done again using the sender's private key. So it is called as a double encryption. Now the receiver will be sending will be getting the message, and the sender's public key will be used to authenticate the message first, and then receiver will be using the private key to decrypt the hash function and thereby the original message. So initially, in order to verify whether the message is from a valid source, the recipient will be using the source's public key first, and then the recipient will be using his own private key as well as the hash code in order to get back the original message. The receiver checks to ensure the original message and hash function results to conform to one another. So it will be checking up with the original message and hash function to see whether the original message is correct, whether the decryption technique was proper. So these are the steps in public key cryptography with digital signatures, wherein we have a double encryption happening at the source end and double verification happening at the recipient. So this is a diagrammatic representation of public key cryptography with digital signatures. So we have the original message that is sent by the sender by XYZ at $52. Then we have a hash function. Now this hash function will be generating a hash number, a fixed length hash number. So that is there 01011001101, 128-bit hash code. Now using the recipient's public key, the first encryption happening. Double encryption, since double encryption, the second encryption happens with the sender's private key. Then we have the ciphertext that will be going through the communication channel. Now at the receiving end, the receiver will be using the sender's public key to authenticate the message. Then using the recipient's private key and the hash, the receiver will be able to get back the original message in plain text. So this is the diagrammatic representation of public key cryptography, wherein we'll be using double encryption. Then we have digital envelopes. So a digital envelope is a technique that is used for symmetric encryption for large documents, but public key encryption to encrypt and send the symmetric key. So it is a technique that basically uses symmetric encryption. In sense, symmetric encryption uses similar keys, and it is used for encryption of large documents, and public key encryption to encrypt and send the symmetric key. So we use a symmetric key, that is same key is used by both the ends, the sender and the receiver, and in order to have the symmetric key protected, we use a public key encryption. Okay, so we're using a symmetric key encryption to send the message, and since this symmetric key encryption will be using a same key, in order to protect that particular key, we will be using a public key encryption technique. So these are the steps in it. A document is encrypted using symmetric key. So both the sender and the receiver will be using the same key for encryption and decryption. The symmetric key which the recipient will require to decrypt the document is itself encrypted using the recipient's public key. So we have, since public key encryption is used to protect the key, symmetric key, the symmetric key is going to be decrypted by using, so the symmetric key is going to be again encrypted by using the recipient's public key. So here we use two encryption techniques. First is in order to send the message, we use a symmetric key technique in which the sender and receiver will be using the same key, and in order to protect the key will be encrypted by using the recipient's public key. So we have a key within a key. That is in sense a message that's going to have encryption done with a key, so symmetric key, and then the key again getting encrypted by using public key of the recipient. So key within a key we have. That is a digital envelope. So we'll stop with this slide. The encrypted report in digital envelope are sent across the web. So we have the encrypted report as well as the digital envelope that's going through the communication channel. Now at the receiving end, what happens? The receiver first uses her private key, his or her private key, to decrypt the symmetric key first in order to get the key. Okay, so the key has been encrypted with the recipient's public key. Now recipient will be using his private key in order to decrypt the key first, and once getting the key, he can use the key to decrypt the original message. So this method is saving time because both encryption and decryption are faster with symmetric keys. Symmetric key encryption, key generation is more fast. Okay, and the protection is double protection. The message encrypted and the key that is used to encrypt the message is again encrypted. Okay, so the key is going to be encrypted, the message is also going to be encrypted. So double protection, wherein key generation is much more faster. There is no technique whereby we actually use combinations or bit combinations to generate the key. Okay, so key generation is faster and protection is double. That is digital envelope. So we'll stop with today. So in today's class, we have seen certain technological solutions for fighting with all those threats that can come during e-commerce transaction, and we discussed basics of cryptography. Okay, thank you so much for your patient listening.